Today's lesson is about practice for finding property of rational functions. For each rational function, find diary. D stands for domain, A stands for vertical, horizontal, and oblique asymptote. H stands for the whole, R stands for the roots, Y stands for y-intercept. For 29, f of x equals x third power over x plus 3. We will work this out by using this diary. For domain, it's an original function denominator not equal to 0. Therefore, we set up x plus 3 not equal to 0, x not equal to negative 3. We will write down x not equal to negative 3. For vertical asymptote line, simplify the function denominator equal to 0. For this rational function, there is no common factor. Therefore, original function basically is the same as a simplified function. Therefore, we can just set up the x equal to negative 3. For roots, your numerator equal to 0. Therefore, we set up x third power equal to 0. Then x equal to 0. I will write down the coordinate way. For y-intercept, basically that is f0. So we got f of 0. Plug in. You will get 0 to the third power. 0 plus 3 equal to 0. For horizontal asymptote line, you need to working on the limits. Or you could say that n greater than m. So no horizontal asymptote line. But we can work this out using that limit. Leading term for numerator is x third power. Leading term for denominator is x. Reduce first. Therefore, we got x squared over 1. That limit as x approaches infinity of x squared. Then plug infinity into this x, you will get the infinity, means no horizontal asymptote line. Oblique asymptote line keywords is 1 more degree, but we know this 3, this is 1. It's not 1 more degree, therefore not available. Whole keywords is common factor. We don't have common factor, therefore it's not available. Now let's go to 30. You have 3x squared minus 5x over x minus 4. First of all, factor rational function, common factor. So we get the 3x minus 5 over x minus 4. For domain, since no common factor for this rational function, original function equals to simplified function. Domain, we just make a denominator not equal to 0. So x minus 4 not equal to 0. You will get the x not equal to 4. Vertical asymptote line, denominator equal to 0. So x minus 4 equal to 0. X equals to 4. Roots. make a numerator equal to 0. Therefore, I got x 3x minus 5 equal to 0. Therefore, x1 equal to 0, x2 equal to 5 over 3. Therefore, you will get 0, 0, and a 5 over 3, 0. For y-intercept, that's f of 0. So f of 0. Plug in. You will get the 0, 3 times 0 minus 5 over 0 minus 4. Any number times 0 will be 0. So you got 0, 0. Horizontal asymptote line. Let's use limit. Limit as x approaches infinity. For leading term, use the original this time. You got 3x squared over x. Reduce. Always reduce first. You will get the 3x. Then you plug x into this infinity. Then you get infinity, means not available. For oblique asymptote line, we need a keyword 1 more degree. This is a 2, here is a 1. Therefore, there is a oblique asymptote for this rational function. How to work this out? Use synthetic division or long division. Since the denominator is a linear function, let's use synthetic division. 3, negative 5, 0. No missing term. Then you get x minus 4 equal to 0. Root in the corner. Therefore, I got 4 here. 3, 12. You will get 7. 28. This is will be the remainder. Therefore, 3x plus 7. Y equals quotient will be the oblique asymptote line. Therefore, y equals 3x plus 7. Whole keywords is a common factor. No common factor for this rational function. Therefore, it's not available. Let's go to 32. First of all, we need to factor top and bottom. So we got the x plus 2, x minus 2 for those factoring. Denominator, since we have 4 terms, so we can do grouping. Turn into adding. Then we got the x squared. X plus 1 minus 4 x plus 1. So we take x plus 1, then you get the x squared minus 4. Keep factoring, you will get the x plus 1, x plus 2, x minus 2. Write down over here x plus 1, x plus 2, x minus 2. Since there are common factor we can reduce, you will get 1 over x plus 1. Make sure get the original function and denominator not equal to 0, which means for this one, you set up not equal to 0. X plus 1 times x plus 2 times x minus 2 not equal to 0. Therefore, x not equal to -1, -2, and 2. For vertical asymptote line, make sure that simplified function. This is a simplified function. Then your denominator equal to 0. So we got x equals -1. For roots, you have to make sure this is a simplified function. Numerator equal to 0. Numerator equals 1. 1 never be 0. Therefore, for roots not available. For y-intercept, make sure f of 0 equals. So we plug 0 into this simplified one. 1 over 0 plus 1, that equals to 1. That is f of 0. For horizontal asymptote line, I will do simplified rational function. For numerator, that's 1. Denominator leading term is x. Then we plug infinity into this x, you will get 0. Therefore, x-axis will be the horizontal asymptote line. Oblique asymptote line, 1 more degree, not available. Hole, we have 2 holes for this rational function. You set up the factor x minus 2 equal to 0. Then x equals 2. Then plug 2 into this simplified function. 1 over 2 plus 1. That is 1 over 3. Therefore, you have 2, 1 over 3. Now working on the other whole, that's x plus 2 equal to 0. X equals -2. Therefore, f of -2 plug into simplified rational function. 1 over -2 plus 1 equals -1. Therefore, -2, -1 is the other whole. For 33, domain, since there is no common factor for this rational function, original function will be the same as a simplified function. Domain, denominator not equal to 0. We set up x plus 3 times x plus 1 not equal to 0. Therefore, x not equal to -3 and -1. Then for vertical asymptote line will be x equals to -3 and x equals to -1. For the root, you have to make a numerator equal to 0. Therefore, we will set up -3 x plus 4 times x minus 1 equal to 0. And you will get x1 equals to -4, x2 equal to 1. Therefore, -4, 0, and 1, 0 will be the roots. Y-intercept, just f of 0. So we plug in f of 0 equals. Put the 0 into this x, 0 plus 4 times 0 minus 1 over 0 plus 3, 0 plus 1. You will get -12 times -1, that's +12, over 3. equals 4. That equals 4. For horizontal asymptote line, let's do the limit of leading term. Therefore, limit as x approaches infinity. We need a leading term for the numerator that will be -3 times x times x. Just make sure for each factor you get the leading term. Denominator, that will be x times x. Reduce, you will get -3. Therefore, y equals -3 will be the horizontal asymptote line. Oblique asymptote line keywords is 1 more degree. Since -3x squared over x squared, the exponents is the same, it's not 1 more degree. Therefore, oblique asymptote is not available. Or you can just write down not available, because for horizontal asymptote line and oblique asymptote line, remember that is either or neither. The whole not available because no common factor. For 34, it's already factored form, and we could say we have common factor. Reduce, you will get the 2x plus 1 over x minus 4 squared. For domain, original function denominator not equal to 0. This will be the original function. Therefore, x minus 5 and x minus 4 squared not equal to 0. You will get the x not equal to 5 and 4. Vertical asymptote line, make sure it's a simplified function. This is the one. Denominator equal to 0. So x minus 4 squared equal to 0. Then x equal to 4. Remember, this is a simplified function. This is the original function. Only domain requires original function. Rest of them, you can just use a simplified function. Roots, you have to use a simplified function. Numerator equal to 0. So we set up 2x plus 1 equal to 0. Then x equals -1 over 2. So -1 over 2, 0. For y-intercept, that's f of 0. Still use a simplified rational function. 2 times 0 plus 1. 0 minus 4 squared. You will get 1 over 16. You can use coordinates. That will be 0, 1 over 16. For horizontal asymptote line, using this limit. As x approaches infinity, 2x will be the leading term for numerator. Denominator will be x squared. Reduce, you will get 2 over x. Then need to plug infinity to this x. 2 divided by infinity will be 0. Therefore, y equals 0. Or you can use this one. N less than m, that will be y equals to 0. Since horizontal asymptote line or oblique asymptote line, that's either or neither. Since we already have horizontal asymptote line, so oblique asymptote line is not available. For whole, keywords is a common factor. Since we have common factor x minus 5, we set up equal to 0, x equal to 5. Then f of 5, we plug in to simplify the rational function. 2 times 5 plus 1. 5 minus 4 squared. So we got 11. Therefore, the whole will be 5, 11.